Question 7. For x greater than 0, f is a function such that f prime of x equals this, f double prime of x equals this. Which of the following is true? Notice that they're all pretty similar, so I guess that helps because we're all looking when x is greater than 0 for increasing, decreasing, and we're looking for when x is greater than e minus 1 for concave up, concave down. That should help us to eliminate some of the extra work in this problem. So essentially, I need to... I'm kind of given, I'm gonna show it to you guys anyway, how to get this, but it's kind of given that obviously 0 is probably going to be a critical point on the first derivative, because if they're trying to figure out if it's decreasing or increasing for x greater than that, then I'm guessing it's got to be a critical point, because if it wasn't a critical point, this question wouldn't make any sense, because we only analyze increasing, decreasing around critical points. So again, like I just said, it's kind of given the fact that they're all the same. It's kind of given that this is a critical point, but I'll show you how to get that, just in case you were unsure. Looking at this function, ln of x plus 1 over x plus 1, there's two ways to find critical points. The first way to find a critical point is to find out what makes the function equal 0. And because this is a fraction, the function will equal 0 wherever the numerator equals 0. And the second way to find a critical point is to figure out wherever a function is undefined. And remember that a function is undefined wherever the denominator equals 0. So in order to find the critical points, we can figure out essentially where the top is 0 and where the bottom is 0. So if I set ln of x plus 1 equal to 0, I can solve for x because remember that ln is just log base e. So this is log base e of x plus 1 equals 0. Now, I didn't teach you guys logarithms, so this might, when I say this, it might seem weird to you, but the way that I teach logarithms to my students is I teach them this thing called the wraparound. It's essentially converting it into exponential form, but some people are not aware of this term that I speak of called the wraparound. But essentially, here's how you do it, is you take the base, you wrap it around to the other side, so it would be e to the power of 0 equals x plus 1. And it looks like this visually, and I think it's a nice visual way to help you remember which one goes where. So e to the power of 0 equals x plus 1. So, I can write that like this. E to the power of 0 equals x plus 1. Now again, I call that the wraparound. You guys probably just learned it as putting it into exponential form, but it's essentially the same thing. Well, anything to the power of 0 is 1, so this is essentially 1 equals x plus 1, which means that x will equal 1 minus 1, which is 0. So that is a critical point, and again, I told you guys that was kind of obvious from what was given here, but this is how to show that it's a critical point of the function. Again, that's what makes the top equal 0. To figure out what makes the bottom equal 0, we'll go back and we'll set x plus 1 equal to 0 and see that x equals negative 1. So this is the other critical point of the first derivative. Do we care about that? Not really, because if you think about it on a number line, negative 1 is here and 0 is here, and they want to know what's happening when x is greater than 0. So they only care about these values here. So this is going to help us a lot, because honestly, we could have figured out that that was a critical point from the very beginning. We didn't need to worry about it. We just knew it was a critical point, and we only cared about what was greater than that. So you don't need to worry about this. You don't need to worry about this. We don't even need to know the negative 1. I mean, it's nice to know just to show you guys the problem, but we don't even need to know it. From the very beginning, I could have jumped straight into the fact that this was a critical point, and I was trying to pay attention to what happened when x was greater than that. So looking at this function, ln of x plus 1 over x plus 1, choosing a number that's greater than 0, any number that's greater than 0, we're going to plug it into the function and see if we get positive values or negative values to see if our function was increasing or decreasing at that point. So let's just take in 1, for example. So our test value that we're going to use is 1. So if I plug that in here, I get ln of 1 plus 1, which is ln of 2, divided by the bottom, which is 1 plus 1, which is 2. Well, ln of 2, if you can think of what log or the graph of ln looks like, whenever you have values that are greater than 0, I'm sorry, not greater than 0, greater than 1, whatever ln is greater than 1, it's going to be a positive number, so the top is positive. Whenever those values are in between 0 and 1, this would be a negative number. So since 2 is greater than 1, this is a positive number on the top, and we have a positive number on the bottom, which means that all of these values over here are positive. So here's what that tells me about my original function. That tells me that my original function must be increasing when x is greater than 0. So it can't be A for sure, and it can't be B because that one said that it was decreasing. So I definitely know it's not decreasing because all the values greater than 0 on the first derivative are positive, which means it has to be increasing greater than 0. Now again, moving on to the second part, I know it's either C or D at this point. In order to figure out if it's concave down or concave up when x is greater than e minus 1, again, the same thing. You could actually solve for when the top equals 0 and figure out when that equals 0, solve for when the bottom equals 0, figure that one out to figure out the critical values and then all that good stuff. But I'm actually going to just cut straight to the chase. I know that I'm looking for what happens when x is greater than e minus 1. So I'm going to just draw my number line. I know that I have a critical point at e minus 1. And again, I know that because they're telling me that. So it wouldn't make any sense for them to ask me about a point that's not a critical value. So that's just kind of a concept of this problem that you need to kind of understand. So I'm looking what happens when x is greater than that value. So essentially when x is greater than e minus 1, what's happening? Is that second derivative positive or is it negative? So concave down or concave up? If I can find a number greater than e minus 1, well, I know that e is about equal to 2.71. So if you subtract 1 from that, you get 1.71. And so a number greater than 1.71 could be like 2. So over here I have 2. So let's plug that into my original function in order to see if it's positive or negative. So I have 1 minus ln of 2 plus 1. That would be 1 minus ln of 3. Oops. Divided by, if I plug in 2 down here, I get 2 plus 1 is 3, 3 squared is 9. So the bottom is definitely going to be, the bottom is definitely going to be positive, obviously, because 9 is positive. So if we know that the bottom is positive, we just need to worry about the top. And 1 minus ln of 3, well, I know that when I plug in ln of 3, I'm getting a number that is bigger than 1. And so 1 minus ln of 3 is equal to, and the reason I know that, by the way, in case you were wondering how I knew that without a calculator, I know that ln of 3, or I know that ln is log base e. So ln of 3 would be log base e of 3, and whenever what you're taking the logarithm of is larger than the base, then it's going to be a number that's greater than 1, essentially. And again, that's because if let's just say you don't know what this equals, but you know that it equals some number, like y. If you do that wraparound thing I was talking about, e to the power of y equals 3. If e equals 2.71 and you need to figure out what power would make it equal 3, obviously you're going to need a power bigger than 1 so that it makes the number bigger. So I know that this has to be equal to a number bigger than 1 so that e can become larger in order to equal 3. So that might be a crude way of explaining it to you, but that's how I know that ln of 3 is greater than 1. So 1 minus a number greater than 1 is equal to negative. So we have a negative on the top and a positive on the bottom, which means all these values over here are negative. Which means that to the right of e minus 1, when x is greater than e minus 1, all those values are actually concave down since it's negative. Which means that it can't be D either. So the only one left to choose would be C. It has to be increasing when it's greater than 0 and concave down when it's greater than e minus 1. So I know that was a super, super long explanation. This one was kind of one of the more difficult ones on the diagnostic and probably will be on the benchmark as well. But hopefully that gives you an explanation of how you can figure those out. If you need further explanation, please just come see me in tutoring or ask me during class, and I'd be happy to help you with this one.